Welcome back. Today we're going to start Chapter 1, Section 2. So we left off solving just one step at a time. So we just did one step, either add, subtract, multiply, or divide to solve for our variable that we isolated. So today we're going to do multi-step linear equations. So lots of big words. What does this basically mean? This means that now we're going to have to do a little bit of practice in taking more than one step. So in other words, we're going to have to add or subtract first, and then we'll multiply or divide depending on the situation. Remember, there are a few steps that we need to do. So we're going to build on this as we go through. But step one, we always have a goal. Isolate variable. So our goal is always to isolate the variable. Now, to get there, it may take more than one step sometimes. So today we're just going to deal with doing two-step. Hopefully you'll find that it's not as difficult as you may believe, but we'll get there. So let's look in our note packet again. We are going to be on page 10 today, and I want to look at a handful of questions just to get your juices flowing to see what steps we need to do. So let's look at example 1. In example 1, I have 3x plus 4 equals 19. Now, let's take and isolate our variable. So I'm going to take and pinpoint what I want isolated, and that is going to be x. To do this, we need to do a couple steps. Let's make some rules that we know we have to follow. First rule is always going to be combine like terms. So combine like terms on the same side of equation. So that's going to be the first thing that we have to do. In this case, you can't combine 3x and 4, and 19's by itself, so we can skip that step. So the next step is going to be combine like terms by adding or subtracting across the equal sign. So what I'm getting at with this particular one is that if you have the same term or the same type of terms on each side of the equation, now you can take and move them across. So if you look here, 4 and 19 are both basically just good old numbers, coefficients. They have no variables attached. So we can combine them. Now remember, you are always pushing away from the variable. So if you're pushing away from the variable, that means the 4 has to do the moving. To do that, once again, we use the opposite operation. Well, 4 is held by addition. So the opposite of addition is, you've got it, subtraction. So we subtract 4 across from both sides. Now don't forget, you're still going to have to justify your steps. So we did a rewrite equation. And then what we're going to do here is we're going to say subtraction property. So I'm going to have 3x equals 15. Now the next step is going to be 2. Well, in this case, we're going to put down divide. So if you notice here, we have to get the 3 away from the x. To do that, we have to use the opposite. And like we talked about in the last video, you do the opposite of multiplication, which is division. So we are going to divide both sides by 3. So we are going to use the division property to isolate that x. So this is like stage 1 and this is like stage 2 because you have 2 steps of properties to undo this. So x is going to equal 5. So last thing we're going to say is rewrite answer. So if you notice, we kind of start off with rewrite equation and we end with rewrite answer. All right, that's not going to donk you. And like I said, this is getting you ready for the I Learn. You will have to take that in your sophomore years. So we need to make sure that you understand where they're talking about when they say write the justifying steps. Okay, so that combined like term we finished here, but then we didn't talk about what we did. Well, that right there is going to be now divide or multiply to isolate the variable. Okay, so now that we have that taken care of, let's try a new problem. Now, like I said, you have some steps here to follow a little bit. So let's look at number 3. All right, so number 3, we're skipping number 2 on purpose if you notice. Number 3 basically is 17 equals z minus a negative 9. All right, folks. So let's look at this. The goal is to isolate the variable. Here is my variable. And we do not have to worry about combining like terms on the same side once again, but what we could do is rewrite that double negative. We have 17 is equal to z minus a negative 9. That's a little too many signs in between the z and the 9. So let's rewrite equation, this time with an actual purpose and just rewrite it. So it's going to be 17 equals z plus 9. Okay, so now we're ready to look at it with clean eyes. It's been taken care of, so step 1 we didn't have to worry about, but step 2 is combine like terms by adding or subtracting across the equal sign. Now we're ready to do that step. Once again, here is my variable I want to isolate, so we're going to use the opposite. Once again, also, we are shoving that 9 across the equal sign. So to do that, we are going to subtract 9. Since we were adding it, we're now subtracting it. So 17 minus 9 is 8, is equal to z. Now remember, we talked about in the last video, if your teacher wants it so that z is on the left, all you have to do is flip those 2 around in your final answer. All right, so let's look at what our rewrite equation, the next step would be. Good job. Subtract. So you have the subtraction property, and then we just have the rewrite answer. This one did not have really 2 steps. Now, I'm sure that the book considered the double negative part as one of the steps, and rightly so it can be, but we would just say rewriting equation. There's really nothing else special we need to do. So let's look at number 4. So for number 4, we have 15 equals 2 plus 4 minus d. All right, this one's got a little more merit to it. In this case, we're going to get to use each one of our steps. So step 1 said combine like terms on the same side of equation. And that right there is what we're talking about. There's your step 1 up top. So I am going to rewrite this. So we have 15 equals 6 minus d. So over here, we're going to do combine like terms by addition. Okay, so that's really step 1. So step 2 is going to be isolating that variable. So now we're going to look at the d. To do that, we're going to say, okay, I need to take, and if 6 is positive on the right-hand side, we need to use the opposite. So the addition 6 is going to become subtraction 6. So I'm going to subtract 6 across, and this becomes 9 equals negative d. So over here, we're going to say subtraction property. Now the last step Basically, we know that we cannot have a negative attached to D. D has to be a positive number. So one of two things can occur. You're going to run into those teachers that say, oh, just flip them around, so it's D equals -9. But the real thing that's happening here is you are dividing by a -1. Or you could be multiplying by -1. -1 is a tricky little critter. He could do both and still come out the same way. So for number 3, we are going to say, since I'm going to keep it positive, multiply by -1. So -1, -1. Now your 9 is negative and your D is positive. So once again, if your teacher wants it rewritten so that D is on the left, you have D equals -9 as your final answer. Now try number 2, and see what you get before we get any further. Let me write down the problem. And you can go from there. Okay, so how did you do? We know, and I noticed I wrote the problem down twice. My apologies. We have to add the 13 across to get it away from the Z on the left-hand side. We have -3 and +13, which will give me 10. We then looked at it and said, oh, 5Z is held by multiplication. So we divided both sides by 5, which then in turn gave me Z equals 2. So if you got that, congratulations, great job. If not, don't give up, we're gonna get there. All right, so this is the last of that stage. What I wanna look at is some multiplication and division, and then we're gonna mix everything up, even more than we started. All right, so I'm gonna look at number 5 and number 6. These two are important problems. We will use them later on as we get into the bigger algebra. So really the first thing that you need to do is to isolate the variable, of course, but we need to also isolate that fraction for the moment. We can move the 5 across. So really our step 1 comes back into play. Combine like terms on both sides first, and then if that isn't the case, then we combine like terms by going across the equal sign. Well, in this case, you can't combine f over 4 with -5, and 9 has no one to combine with. So that step's done. So the second step says, now take and do the opposite to get the 5 across, since 5 and 9 are both coefficients. So when I do the opposite of subtraction, of course, is addition. So I get f over 4 equals -4. So the first step of this is done. So if we use our justification, so justify, we are going to take and say the first step is, of course, to rewrite equation. Step 1 in the actual step now is going to be addition property. Step 2 is going to be using, in this case, multiplication. We know it's going to be multiplication because we have f over 4, which indicates division. The opposite of division, of course, is multiplication. So f is going to equal -16. So we will use multiplication. So multiplication property. And then, of course, the last thing is rewrite answer. All right, remember you can always use your check step. And with these, I'm going to show the check steps because they're a little more complicated. So in this case, I'm going to have -16 over 4 minus 5 equals -9. Well, we still have to take it step by step. And let me label this check step before we go too much further. So we're going to end up with 4 divided into -16, which is -4, minus 5 equals -9. So -9 equals -9, and it checks out. All right, so far so good. Look at number 6. This one also is a little unique. On this particular one, it is one great big fraction. Now, do not panic. This is actually quite a simple procedure. So, like we talked about before, let's go through our steps. Step 1, our goal is to isolate the variable, of course, but step 1 is going to be combine like terms on each side of the equal sign. We do not have that at this point. So we're going to move into the next one, which is going to be take and add or subtract across. Well, this one is a little unique. In this case, we cannot add and subtract until we get rid of the division because it's tying two terms up above together. Now, if two terms are held together above, then you must clear the fraction to make everything work. So we are going to do the opposite of division, which is multiplication. So I am going to multiply both sides by 3. That will cancel them out, leaving Q. Now go ahead and handle those two signs. That's going to be minus 5 equals 8 times 3 is 24. Your last step is to add 5 across, and you get Q equals 29. Now, like I said, not all the time are our steps going to be out of order. They're normally pretty straightforward and always in order, but occasionally you will have these. Now, this is based off an average problem. So when you're dealing with averages or something of that sort, you're going to have some mismatch, basically steps as you go through. So when we do our justification, step 1 is going to be clear the fraction. So to clear a fraction, we say we multiplied, we did our multiplication property. And of course, rewrite equation. If you're wondering where that went to, you do rewrite equation first. We did the multiplication property. And then once we did that, then we used addition property. And of course, our last one is rewrite answer. So for the check step for this one, you're going to have 29 plus negative 5 over 3 equals 8. Well, we know 29 minus 5 is 24 over 3, which gives me 8 equals 8. And it check stepped out. All right, excellent. So now that I've given you a few challenging ones, let's go into what if I have multiple variables. Now what I mean by that is the variable itself is the same, but the numerical coefficient in front of it may have more than one. So let's look at a couple of these, and then I'm going to have you guys do a few of these on your own. We're going to stop before we get to the distributive property and make that a separate video. So let's look at number 7 through 10. So for number 7, we have 5x plus 3x equals 28. Ladies and gentlemen, this is just as simple that as we've been doing above. We combine like terms on the same side as our first step. Well, in this case, there you go. We add those two, which give me 8x equals 28. Now you are ready to take and use whatever other operation we need. Well, in this case, we don't add or subtract to get the x isolated. We're going to take and we are going to divide because the opposite of multiplication, of course, is division. Great job. So x equals 4. To save some time and some space, I'm not going to show the justification steps, but you need to keep practicing them so you are ready when you get to your I-Learn testing, or if your teacher puts that on your exam, like I am probably going to do with my students. All right, so look at number 8. 5z minus 2z minus 4 equals negative 7. All right, so take a moment, pause the video. Did you pause it? All right, let's work through it together. So the first thing we're going to do is combine like terms before we move across the equal sign. So when I combine these two, 5z minus 2z is 3z. Let's recopy the rest of the problem. Now, The second step said to take and move things across the equal sign to combine them. So -4 and -7 are on opposite sides but can be combined. Be careful when you move across the equal sign, it changes the sign. So instead of -4, it's going to become +4. So 3z equals -3. So our last step is going to be the opposite of multiplication is division. So I divide both sides by 3, so z equals -1. Okay, are you feeling confident? Let's try number 9. So number 9, I'm going to let you have full reign on. So I'm going to put this on here, and when you get done pausing the video, you can then check your answer and see if you got it correct. Okay, ready? Go. Okay, how'd you do? Yeah, I know that was sort of a dirty trick. I gave you a practice one. There was a fraction for an answer. But let's see how we did. You combined the 12 and the 2 and got 14x. You then took and rewrote your problem with the +4 equals 39. Next step, we had to subtract the 4 across to get the x isolated. So when I did that, I ended up with 14x equals 35. Now, we know 14 does not go into 35 evenly, and that's okay. Fractions happen. So x equals 35 over 14. However, you cannot leave a fraction that is able to be reduced. So we reduced it by dividing a 7 out of the top and the bottom. So we ended up with 5 over 2. Okay, so let's try one more. Let's see how you do with number 10. Once again, pause it, get ready, set, go.